So hello everyone. Today we are going to start with session number 17, and in this lecture also we are going to go for part practice. So today we are going to make this part, you can see here. So this is one of the component of a machine and we are going to make it in solid edge. So you can see here, first we are going to see what actually are the features that are going to be there in this part. So here this part is completely circular in cross section, also having internal cuts as circular in cross section. But here in this internal portion you can see here this portion, you can see this portion here, and this top view also showing only one internal feature is being cut in a rectangular way. Other than this, all the features are in diameter symbol showing that the internal cuts are round in nature. So we are going to use majorly revolve boss and revolve cut command here, as well as we are going to go for this counter bore holes. For that we are going to use hole command. We are also having one dowel hole here combined with one drill hole. I need to zoom apart little bit here. So there are chamfer also on the starting edge, at the lower edge, at the corners of this outer body, as well as on the sides also. So there are total 7 chamfers on this body. Some internal radiuses also there. So to start with the part, we are going to make this outer body, and then we are going to go for this revolve cut. We'll start with solid edge here. We are going to select revolve command, select the front plane, and now we are going to make the half of the sketch of that particular body. First I'll make the revolve axis. I'll select this line as an axis of revolution here. Now we are going to calculate the total height. So the total height given for this part is 74 mm. You can see here in section view AA. That is this section view. Intersecting this dowel hole also. So in section view you can see this total height is given 74. The total width of this part is given as 136 diameter. So I am going to select the height first. I'll take it as 74. Say auto scale to dimensions. Next we are going to go for the diameter size. Now this projection is been made here, that is of 5 mm having diameter 92, and then the larger diameter will come of 136. So we'll start with the 92 diameter here having projection of 5 mm. So I'm going to take this value as half of 92. 92 by 2. I'll directly put the value on the scale in fraction form only. So here the value is coming 46. Next, the height is 5 mm here. Next, we are going to go for the other diameter, that is this larger diameter of 136. So we need this value to be taken half of 136. We are going to make this line first. Here it is shown. This height of the cylinder having diameter 136 is 57 mm. So here this height 57 mm and this diameter 136 by 2. It is taking aligned dimension. We need to undo and give the other dimension again. The dimension is coming inclined. It is because the properties of line we have selected by 2 points. We need to change it to horizontal or vertical, then it will take horizontal dimension. So here the dimension was 136 by 2. So whatever the diameters are, we are going to take only radius here so as to revolve this profile around the axis, and you will get the correct diameters after revolving here. Next, after taking this value 57, next we are going to update this value by 57. This height was 57 here. Next again we are going to go for this diameter, that is 102. This outer diameter you can see here, it is of 102. I am going to end this profile on the origin again so as to make the close portion. Now the last radius value, it will be 102 by 2, that is 51, and then we are going to go for close sketch. Now you can see here it is completely been revolved. If we go on this extend step, it will show you the angle option. If I want to revolve it partially only, then I am going to say half, that is 180, and we can change the direction also here. You just need to flip the mouse, but this time it is going to be 360 only, complete round. So I am going to take this option, that is revolve 360 degrees. Say finish and cancel. So this outer body has been made here. Next we are going to go for this internal feature using revolve only. So first these two profiles of diameter 86.5 and 72 are going to be made. Then this gap, that is this rectangular cutout, we are not going to make this sketch here. Lastly we are going to make this 90 mm diameter cutout profile, and then we are going to go for revolve cut feature. So for that again I am going to on this base reference plane so as to select the mid plane here. For revolve cut, always select the plane that is causing maximum cross sectional diameter. So that plane is front plane here. I'm going to say sketch on this plane and going to go for this internal features now. So here you can see this upper diameter is of 86.5 having depth of cut as 14 mm. That cut is going to be started by this outer diameter of 92. So this was the diameter of 92. I'm going to start this from this edge only. So here I'll put up the dimensions. So this will come half of 86.5. 86.5 by 2. Next the height was given 14 mm. So I'm going to take this height as 14. We'll continue with the profile, the second diameter that is 72, and we are going to close it there. So here this profile I'm going to close it here. The diameter will be half of 72, 36, and the depth of cut for this one is 20 mm. You can see here diameter is 72 and depth of this diameter is 20 mm. So I'm going to take this dimension as 20 mm. Next we are going to make one more profile that is of this 102 diameter having depth 20 mm. So again we can go for second profile here. We'll see whether it will take or the second profile or not. Here the diameter is 90. So I'll take this value as 45 and the height is 20 mm. Next we are going to say close sketch here directly. Say finish and cancel. So now we are going to go for this revolve feature. We are going to say select from sketch as we have made this sketch first only, and then we are going to select the sketch now. Select both the profiles, say OK. Now we need to show the axis of revolution here. So I'm going to say this Z axis and axis of revolution here, and you can see both the profiles are being cut here, leaving the material in between. Say finish and cancel. We'll hide these profiles here, also hide the planes. Now it is not completely been made through all cut, as we are going to take one more cut here that will be of this feature, this rectangular feature you can see here. We need to cut this rectangular feature on the remaining material in between in this cross section. Here we have not made this cut, so we are going to make this profile and then we are going to cut this profile. So we'll start with this profile to extrude cut. I am going to say sketch to this upper face. Next we are going to make the rectangle here. Now this rectangle is little bit tilted, you can see here. This reference angle is also shown in brackets. That is from horizontal it is 8 degrees. Now the rectangle size we are going to take here is of 48 by 24.6. So here I am going to take the type of rectangle here as by 3 points, first, second and this third point. Now we are going to provide the sizes and make this rectangle symmetric with this center. So first we are going to provide the sizes here. So this align size you should take the type of dimension here as by 2 points. So this value it is taken of 48 and the other value is of 24.6. Now I am taking this rectangle 24.6 by 48. It is because we are going to draw circles on the endpoints of this rectangle to obtain this profile shape. So here 24.6. We also need to give angles. For that I am going to make construction line here. Going to say construction line, and now we are going to provide the angle of 8 degrees here. It is tilted at 8 degrees. Next we are going to draw two construction lines till origin. I am going to say this line as construction. Next we are going to go symmetric axis. Select this line as a symmetric axis. Then select the relation symmetric and select both the sides. Next we'll drag it little bit downside here. Next we are going to draw for horizontal orientation this line. So this line also has construction. Next select axis for symmetricity. Then go for the two sides to make this symmetric with this axis. Now this complete rectangle that is 24.6 by 48 has been defined. Next we are going to set this all the four lines as construction. Select construction and say chain selection. Click on the rectangle. Next we are going to draw the circles here. So now the diameter of each circle here it is given, that is of 10 mm. So we'll select this and say diameter as 10. Another circle, we need all 4 circles here. Say equal relation all the circles. Say equal relation to all the circles here. Next we are going to offset these lines. Here we need to calculate the values, that is this vertical distance was 24.6 and the boundary we require is of 30.6. So difference between these two values is of 6 mm. So we will take offset command, select the type as single and go for the offset value of 3 mm. Say accept and then click on the side we require. At bottom side also select the line, put up the value of offset and say accept. Now we are going to trim here the circles. Same we are going to do on this side also. Next we are going to go for offset on this vertical lines also here of this rectangle. Again select the offset, go for the 3 mm value, say selection as single type, accept and put it here. Next the other line on the opposite side, again say offset, select the line, say accept and show the direction of offset. Again we are going to trim these lines to make the sketch completely constrained. Trim the circles also here. Same on this side. Now this complete closed profile has been made, having internal rectangle as 48 by 24.6 and this external line distances as 54 and 30.6, these lines. So next thing we are going to do here is making this as a cut extrude. Say close sketch and go for the features and say extrude cut. So in extrude we are going to select cut option, select the profile you need to cut, say OK, and this cut will be through all. So in extend step we are going to say through all. So the direction at bottom side and say finish. Now hide this sketch. So we can see here in top view this part has been made having 8 degrees rectangular cutout with corners as rounded here. Next we are going to go for the chamfers. All the chamfers, there are total 7 chamfers here. It is because of chamfer only, that's why we are seeing two edges here. We can see it here in this section view BB. This chamfer was of 2 by 45 at the upper side as well as at the lower side of the rectangular cutout. So select the chamfer command here. Go for this face selection instead of chain and select all the faces we required here. As the chamfer is coming all around the edges, I am selecting all the faces here. Then go for this options option, select the type of chamfer. We are given with the value of angle and distance. So I am going to select this option, that is angle and setback, say OK. Next we need to go for this setback value. So this setback value was given here 2 by 45. Distance was 2 mm, angle was 45. Next going to select this option, that is edges. We need to select all the edges now after selection of faces. Now this chamfer has been appearing here with the value of 2 by 45. Same on the bottom side also it is given. So I'm going to flip the part and go for this side chamfers also at the bottom side. Next we are going to go for this upper edge chamfer here. So this upper edge chamfer also you can see here, it is given of 2 by 45, this outer edge chamfer. On this edge also we need to go for 2 by 45. Again select the chamfer command, select the face option, select the face required, say OK, and now we need to select the edge required. Say 2 by 45 and again say OK and finish. So this outer edge chamfer is also been made here. Next we need to go for this chamfer that is on the outer cylindrical edge. So this projected cylindrical edge. So at the internal boundary we need to go. Select the chamfer. Say select face. Say OK. then select the edge and we are going to put the value here as 0.5, say finish and cancel. So now this chamfer is also been made, that is of 0.5 into 45 on this edge. Next, we are going to go for this chamfer now at the internal feature, that is of 1 into 45. Here the value was given 1 into 45, it is on two edges, that is this internal edge also 1 into 45 and the outer edge also 1 into 45. On this edge, select chamfer tab, select the face, say OK, and then select the edge required, go for the value as 1 into 45. On this face also, next at the bottom outer face on this edge, again chamfer, select the face, say OK, select the required edge, say 1 into 45, say OK. So now this outer chamfer of 1 into 45 has also been made. Next we are going to go for this internal chamfer at the bottom side. Say chamfer tab, select the required face, say OK and select the required edge. Say OK again and finish. So now we have made all the chamfers here. Next we are going to go for this radius, that is at the upper corner, the cylindrical projection, the radius is of 0.75. You can see here. So here we need to go for the radius of 0.75. I'm going to select round command and say this value as 0.75. Say preview and finish. So you can see this fillet has been made here. Again one more fillet is given here, that is at the internal section. The first cutout, that is of radius 2. So on this edge, round with radius value of 2 mm. Say preview and finish. Next again one more radius is given at this outer section of radius 1. So here we need to go for this radius, select the edge and say this value as 1. Say preview and finish. Now all the radius and chamfers are been provided here. Next we are going to go for these hole cutouts. So on PCD of 120 we can see here this counter bore holes, 3 numbers equally spaced with having the circle cutouts at the PCD of 120 mm diameter. So here at the top view you can see here this counter bores, external diameter is 11, internal is 6.6. So I think M6 will be the hole required so as to make this counter bore using hole command. So again we are going to set top. We need to orient it properly first and then go for this counter bore. Select the hole tab, select the face on which we require to put the counter bore hole. Next place the hole required at the position and then I'll go for this close sketch. We need to put up the option saying counter bore hole. So I'm going to select the counter bore here of M6 size and fitment I'm going to take normal here. So this internal diameter by default is coming 6.6. You can see here this internal diameter was given 6.6 having end condition through all and the upper diameter was coming 11 mm. So here also the upper diameter is given 11 mm. We don't need to customize the sizes in counter bore here, but still the depth of cut it is given 6.8 in standard hole. We are going to customize that depth and say it as 25. You can see here this value. So here we need to say 25 and we need to place it on the dimension. So for that again I am going to say whole step and we need to go for the smart dimension so as to place it from center. As the PCD was given diameter with 120, so I am going to take it 60 mm here. Say close sketch and finish. This counter bore has been made here. Next thing we are going to do here is pattern this hole. So I am going to select pattern tab, select the feature required to be patterned, select say OK, then select the required face on which we require the pattern, then go for the type of pattern, that is circular, select the part center, then select the feature center, go for the options here showing the number of entities or count, say as 3, and show the direction, any one direction we need to click and then say close sketch. So this counter bores are also been patterned here. Lastly we are going to make this two holes that are dowel hole from the bottom side having depth 25 and diameter as 8 with the fitment of H7. The depth is 25. Now this dowel hole will come on the same PCD distance, that is of 120. So at the bottom side we require the hole and it is coming at the center here. You can see this section AA, this circular profile quadrant center is coming here at vertical center. So go for this hole command again. Select the face on which we require dowel hole. Go for the position of dowel hole. I'll take here the straight position. We need to provide the dimension. This will come at 60 mm as the PCD was given 120. Next we are going to say type of hole. For that I'm going to say close catch. Go for options option again and select the type of hole here as dowel hole having diameter of 8, and here we need to provide the tolerance also, fitment with tolerance. So here we are applying fitment for hole, that's why we are going to select this option, that is hole, and the fitment here is given as H7. So I'm going to select H7, say OK. Again the end condition is shown. The depth of cut it is given here 25. So I'm going to say hole extends finite extent and here the depth will be 25. Say finish and cancel. So now this dowel hole has been made. Next, from the upper side having same PCD we are going to make one more hole, that is a simple drill hole of diameter 6. I'm going to say it through all. So we are going to select this top view. We are going to orient this view properly. Then we are going to set transparency so as to take the center of the dowel hole at the bottom side. Next we are going to go for hole command. Select the type of hole here as simple drill hole having diameter as 6 mm. So here the diameter is 6 mm. You can see here it is given diameter 6 on this same PCD. So I am going to take reference of this face. Say close sketch. We don't need to define the position again here as this is taking the reference of dowel hole. So now you can see both the holes are now been made. I am going to say again the view style as visible. We are going to apply the material here so as to finish the object. So here say view tab part painter. We are going to go for type of selection as body and here we are going to select the color as gold. Click on this part. You can see here this complete part has been made. From the top side also you can see I'm going to orient it properly here. This was the top side. I want to be oriented in isometric view. In this way this part has been made. If you want to render this part, just go to this tools option, select this key shot render option. It will take a little bit time here. If you want to adjust the brightness and light, we can adjust them here.